A right triangle has sides of 5, 12, and 13. We want to find the measures of its acute angles. Now you say, why do we ask for the acute angles? Well, we know the right angle has an angle measure of 90. All right, so we're going to be looking for the two acute angles, and the only clue we've got is that it's a right triangle and it has lengths of 5, 12, and 13. So let's see where this is going to go. All right, let's take a look at and draw this thing out, see how we're going to work it. We're going to first create a right triangle. Need to do that, all right? And one of the lengths is 5, one of the lengths is 12. And then we're going to roll this thing all over the place, it looks like. And we're going to connect right there and get our length of 13. And we'll box this angle right there. That makes our 90-degree angle. The question is, and I'm going to put these just to make this a little bit easier, let's go with A for the angle at the top and B down here at the bottom, and we'll look for C. And the question is, we want to know what are B and A. Now yesterday we gave you a situation, opening line here. We had a right triangle that was isosceles, all right, and that was where both the legs were the same and the angles turned out to be congruent, all right? And this is not going to be the case today. These lengths are different. These legs are 5 and 12, so these angle measures are definitely going to be distinctly different. What do we do? Well, we know this side is going to be our 5. This is going to be 12, and our question is, we'll call this down here, what is X? What is that little thing? I always like to call it X. I don't know what it is, but we're going to try to figure it out. And the deal is, what we're going to have to employ, and some of you are going out there in geometry and said, oh, I've seen problems like this. Some of you in those pre-calculus and algebra 2 classes, I've seen problems like this. It's going to be trig. We're going to use trig on this, exactly, because we don't really have this great special triangle situation. We have a definite situation. We've got to go after the trig, all right? Now, we do have a 13 right up here for the hypotenuse. By the way, folks, you can't just throw any numbers up here. You've got to have a right triangle triple or something that will go a squared plus b squared equals c squared. In this problem, we have 5 squared, which is 25. We've got 12 squared, which is 144. That adds up to 169, which is 13 squared, all right? So again, not just any numbers are going to make this work. They have to make the a squared plus b squared equals c squared come to pass, all right? So that's the first thing you want to quickly test when you've got these lengths. Make sure someone has not thrown you a bogus length. Another thing, the hypotenuse is always the longest length of the right triangle. Some FYI moments here, okay? Now you say, well, okay, what's this trig stuff about? Well, on your calculator, if you'll notice, there's probably these buttons that say SIN, COSTAN, and you're probably going like, what are those for, and when am I ever going to use them? So here we go. Let's see if we can get them used here. But first of all, it's all about these relationships. The sine of, and we're going to go with sine of B here, is equal to the opposite leg over the hypotenuse. And that's our starting point. That's our starting point. Now notice what that is. This says the sine of B equals 5 over 12. You say, what in the world is that about? Well, we got a little button on the calculator. We've got a little button in our heads, and we have tables that will allow us to go from that fraction to the degrees. We'll catch that here in just a second. Let me get the rest of the formulas up here. There's also the cosine, by the way, SIN, some of you are going, that says sin. Well, it's short for SINE. That's the sine of B, okay? And B is our angle B down here. In this case, it's sine X, we could say also. Cosine of B, which is COSINE, it's equal to the adjacent leg over the hypotenuse, okay? And last but not least, we have this thing called tan. If you look on your calculators, you see that tangent, and it's short for tangent, T-A-N-G-E-N-T, and tan B is equal to opposite leg over the adjacent leg. Now what I want to do, I want to go ahead and put these fractions in here a little bit, all right, for us. Let's pull that down. And here we go. The sine of B is equal to 5 over 13, because you see 5 is opposite, 13 is the hypotenuse. And the cosine would be 12 over 13, because adjacent leg, that's the one that runs into angle B, is 12. We put it over 13. And then last but not least, we've got this opposite leg, which we've decided is 5, over the adjacent leg, which is 12. Now, those are the ratios. You say, well, whoop-de-doo, what do we do now, all right? Well, if you drop my lower third out there, guys, we will show where we're going to go with this problem, all right? We are going to use what we call an inverse function. we're going to take the sine in its inverse, which means we're going to transfer back 2 degrees on angle B. All right, or in this case, you could say x there, sine -1x. And it's a little -1. And on your calculator keys, usually you get there by the second button. We'll look at that just a second, all right? But what we're going to do here, we're looking for the sine inverse of B. And I'm going to get rid of that for just a second because that's not really what we're looking for. We're looking for the sine inverse of 5 divided by 13. We're going to take the ratio, and that is going to get us back to x, all right? So if we take, and by the way, remember that's associated with angle B. So here we go. We got sine inverse of 5/13 equaling to x. So on the calculator, let's go there, guys, if we can. Let's see what we've got going. We have some keys that you notice there. There's sine, there's cosine, and there's tangent. Now don't just press them as they are. See where my little cursor is flying, folks? Some of you are going like at home, oh yeah, we see that. Right in the middle there, the buttons. But I'm going to hit this little blue button at the upper corner there, bluish gray, and we're going to hit the second button. And all of a sudden, I should be seeing a little bit of, yeah, I've got a little cursor action there. If you notice, that's changing. And I'm going to press the sine button, and I get the sine inverse, -1. And see, that's what I prompt with. That's what it prompted me, just like I was telling you what we're going to do over here. And it's going to give us 5 divided by 13. And we'll close that parenthesis. And we press enter. Everybody hold your breath. Let's have a magic moment. And we get 22.61. Woo, it rambles on and on. We'll take you to the nearest tenth. How about it? So our x, folks, and our x in this case is 22.6 degrees. That's our value, 22.6 degrees. Now you say, all right, Ernie, that's what x is. It says find the other acute angle. What are we going to do to find the other acute angle? Well, you know what? We can deal with it as subtracting from 90. These two angles add up to 90. So if we've got 22.6 here, looks to me like we should have about 67.4 for our other one. We'll call that little guy y up there, okay? So our y will equal, what did I say, 67.4 degrees. And if you add those two together, it comes out to give you 90. Now, let's go back to the calculator just a minute. What if we use cosine and 12 over 13? Let's hit it real quick, and we got a caller I know waiting for me. Let me get one more shot in here. Should you use cosine? Let's go second. Go cosine. It says, let's see, hit that again, clear. Hit second, boom, cosine. And we'll fill in this time 12 divided by 13. And folks, we should get the same answer. Your calculator's pretty smart. There it is. You could also use tangent inverse for 5 over 12. All of those will get you the same degree measures, and then simply subtract from 90, get your other angle. So great complimentary problem there for Problem of the Day.
For more math help, visit tnlearn.org.